All right. Not 1,750. That's the next problem. We get 8.63 grams of water. All right. Carbon monoxide will burn in the air to produce carbon dioxide. We're solving for volume of oxygen, and we're given liters or volume of carbon monoxide. So starting with 3,500 liters of CO, we know that we're not at STP, so we're going to do P times V, 1.04 ATM, divided by 0.0821 liter atmospheres over mole Kelvin. And then we'll multiply by 30 plus 273 would be 303. And when we put that in, we get 146.3 moles of carbon monoxide. Now, there are 2 moles of carbon monoxide to every 1 mole of oxygen. And we want volume, and we're still at the same parameters. So now what we're going to do, I'm going to erase that. And we're going to take the answer we get there, which, well, we're in moles now. So instead of taking the answer, we'll just multiply. We're solving for V is equal to nRT over P. So now we know moles times 0.0821 liter atmospheres over moles Kelvin times 303 Kelvin divided by P, which is 1.04 ATM. And now we get 1,750 liters of oxygen. Number 14. One method used in the 18th century to generate hydrogen was to pass steam through red-hot steel tubes. This is the reaction. In order to obtain 2 liters of hydrogen gas, what mass of iron must react? So we're solving for mass of iron. And look here, we're given the volume and the temperature and the pressure. So we start with 2.0 liters of hydrogen gas. We'll do PV equals nRT, so PV over RT. There's the volume. The pressure is 0.95 ATM. Divided by R, which is 0.0821 liter atmospheres over mole Kelvin. And our pressure, our temperature, 273 and 75, 348. And that'll give us 0.0665, I believe. Now, we're going to go from 4H2 to 3 moles of iron. We want to know mass, so we're going to multiply by the molar mass, which is 55.85 grams in 1 mole. And the answer we get is 2.79 grams of iron. Number 15. Sodium azide decomposes according to this equation. What mass, this is our unknown, of sodium azide is required to provide nitrogen that will inflate a 75-liter bag? So our information that we know is 75 liters times 1.3 ATM. divided by 25 plus 273 would be 298 Kelvin, and the ideal gas constant 0.0821 liter atmospheres over mole Kelvin. When we do that math, we get 3.985 moles of nitrogen. 3 moles of nitrogen are produced for every 2 sodium azides that are reacted. All right. And that gives us moles of sodium azide. Now we have to change to grams. 65.01 grams in 1 mole. 173 grams of sodium azide. Now, just a note, look at what it's producing. It's producing sodium, which reacts with water and burns, creates hot hydrogen gas. So that is kind of a nasty byproduct of airbags, but they have a way to fix that nowadays. All right. Did I not have any more on that page? No. So let's go on to stoichiometry worksheet number 5. All right. Methanol reacts with excess oxygen in the air to form carbon dioxide and water vapor. How many grams of water are produced if we know 15 grams of methanol? So, simply 15 grams divided by the molar mass of methanol is 32.04. The ratio of methanol to water is 2 moles of methanol will react and form 4 moles of water. And it's asking for grams of water. The molar mass of water is 18.02 grams in 1 mole. And I got 16.9 grams of water formed. How many moles of oxygen would be consumed? Well, we again start with our 15 grams of ethanol, methanol, divide by 32.04 grams in 1 mole. Now I'm in moles of ethanol, but this time I'm solving for oxygen. So I'm going to put 2 moles of methanol on the bottom and 3 moles of oxygen on the top. And 0.702 moles. All right, number 2. We are solving for grams of lead nitrate or lead. We're solving for grams of lead nitrate. And we are told that we have volume and molarity of potassium iodide. So, starting with 0.0750 liters multiplied by 0.200 moles per liter, that gives us potassium iodide moles. There are 2 moles of potassium iodide that will react with 1 mole of lead nitrate. And We're solving for grams, so we need to know the molar mass of lead nitrate, which is 331.21 in 1 mole. And when we do the math, we get 2.48 grams of lead nitrate. All right. For letter B, we're using the same equation, 2Ki plus lead nitrate. Lead 2 nitrate forms lead 2 iodide plus 2KNO3. But this time, we want to know how many grams of precipitate. And if you look up lead iodide, it will precipitate. It is insoluble. So we're solving for grams of lead iodide. And once again, we have our starting point of 75 milliliters and 2 molar Ki. So 0.0750 liters times 0.200 moles per liter of Ki. The ratio is 2 moles Ki to 1 mole lead iodide, lead 2 iodide, times 461.07 grams in 1 mole, and that gives us 3.46 grams of PbI2 formed.